What's going on, y'all? It's Damien with the DevSec Blueprint once again with another technical video. And in today's video, we're going to be performing SAST scans against code repositories using SonarQube. If you haven't taken a look at my video about SAST and DAST concepts, I highly recommend you look at it before we get started, since it'll give you a pretty decent overview of what SAST scanning is. And with that being stated, let's get right into it. Before we start talking about SonarQube or sonar scanning in general, let's talk about some of the prerequisites, right? On what it is that you actually need to have installed on your machine in order for you to be able to participate in this activity. So the first thing that I would recommend that you guys need to have installed is Docker. And the reason why is because we're going to be launching the application from Docker and also running the scans using Docker as well. The second thing that I want you to have installed is VS Code. And the real reason behind having that installed is really for you guys to be able to look at the markdown file and also look at the Docker compose.yaml file in a pretty format. And that's essentially the main reason why. You don't necessarily have to have it installed if you don't want to, but I always recommend installing it anyway because it's one of the best IDEs out there. And I want to mention also that the link to all of the things that I just mentioned, including that YouTube video about SAST scanning and DAST scanning, or the concepts in general, is located in the description. So now that we've covered the prerequisites, let's talk a little bit about SonarQube. All right, so let's talk a little bit about SonarQube. So the key thing about this tool is that, number one, SonarQube is a self-managed automatic code review tool that systematically helps you deliver clean code. I've used SonarQube several times within the past to help me out with DevSecops related work or really to scan my code. And the beautiful thing about this tool really, or this application, is that it can be integrated with various different IDEs. You can integrate it with various different pipelines to build, test, and deploy your code, and to be able to scan your code for all kinds of issues unrelated to just security issues, but it could be refactoring issues that they have or that your code has, and so many different other things. The key thing is that SonarQube, when it talks about writing clean code, there's basically this type of clean as you code or clean code standard or approach that Sonar has implemented or embedded into their application that pretty much creates this thing called the quality gate. And that quality gate is like a score on how well maintained and how secure your entire application code base is. So there are various different types of features that SonarQube has, but one of the things that I really wanted to point out was, and I'm going to kind of scroll down here, is that it has critical security rules for vital languages. So it has support for well over, I think it's 30 languages, if I'm not mistaken. Again, you can integrate it into different DevOps platforms and CI platforms like GitHub CI or GitHub Actions, GitLab, Azure, Bitbucket, 30 plus languages and frameworks and IAC platforms, high interoperability, there's super fast analysis, shared and unified configurations, and then SonarLint IDE integration. So all these different things really kind of help make up SonarQube as this really robust software solution that can be integrated into various different stages of the SDLC. But the key thing is that for SAST scanning purposes, we're only going to be focused on leveraging SonarQube and the Sonar Scanner that it comes with to be able to identify security vulnerabilities within our code. So the one thing that I wanted to highlight before we move on to doing the technical activity is that SonarQube is free. It is open source, and you don't have to pay for it unless, of course, you want to go with the Enterprise Edition or the Data Center Edition. And then I'm pretty sure you have to pay for that. But for our particular case, we're going to be using the Community Edition, which is free for us. And the beautiful thing about it is that it still comes with all of those features that we can leverage to be able to scan our code for any type of code smells or issues, refactoring issues, duplication, and security vulnerabilities. So now that you guys have a fundamental understanding of SonarQube, let's talk a little bit more about Docker Compose, which is what we're going to be using to basically deploy and manage our SonarQube application. So Docker Compose is basically a tool for defining and running a multi-container application. The key thing about it is that it's super efficient because it's all streamlined, and it also allows for an efficient development and deployment experience. So you don't necessarily have to worry about deploying too many containers by executing the Docker run command multiple times. You can just do Docker compose up once, and then it basically handles everything as long as you have everything specified within your YAML file in the way where it is acceptable, of course. So the thing with this is that Docker Compose simplifies control of your entire application stack, making it easy to manage services, networks, and volumes in a single comprehensible YAML file configuration. And that's something that we're actually going to talk about or touch on when we're going through the technical activity, right? So with the single command, you can basically start all the services from that configuration file. And the beautiful thing about Compose is that it works in various different environments: production, staging, development, and testing. And you can also include Compose, or you can leverage Docker Compose in your continuous integration workflows or CI workflows. So now that we've covered Docker Compose at a very high level, let's get into the technical activity and let's just start playing around with SonarQube and Docker. So the first thing that I'm going to do is, number one, I'm going to clear my screen. And the second thing that I'm going to do is I'm basically going to kind of walk through this file with y'all in more detail. But the key thing that I want y'all to understand is that with this README file, this code is going to be checked in to GitHub. And this README file is going to basically have the summary of what SonarQube is, some of its features, what Docker Compose is, and also steps on how to run SonarQube and how to run the Sonar Scanner. So I'm basically going to be going through this with y'all step by step. So this is the Docker Compose YAML file. And you can see here we have three things. We have the version, which is arbitrary. We can set the version to wherever number we like. But in this particular case, I'm going to just set it to version 1. You have your services, which are the services that can be directly or dynamically mapped to your Docker Compose file. And you basically just want to, you can name it, whatever it is that you want to name it. And then you specify the image for that particular service. So in this particular case, we have two services. One is SonarQube and the other one is the database for SonarQube, which runs off of Postgres. And we're basically passing in that image for the SonarQube service, as well as the image for the SonarQube database, and some environment variables like, username and password, login, et cetera, et cetera. And there's port numbers or the port mapping, and there's also the volumes. And then the volumes, these are all directly associated with SonarQube, and these are things that we really don't want to touch it. And it's also something that SonarQube itself depends on. You definitely want to make sure you have this checked out on whatever machine you're using. And you're basically going to just run this command, Docker Compose up. And what that command is basically going to do is stand up this entire application. So you can see it's basically running and it's downloading all of the Docker containers, the Docker container images for SonarDB and also for SonarQube. And this is actually going to take a little bit of time. So I would say give it about roughly 4 to 5 minutes, and then we'll come back and we'll talk a little bit more about what we see within the application and actually start setting things up. All right, so SonarQube is fully operational. You can see that it's basically stating it here in the CLI or in the terminal. So let's go ahead and let's log in. So what you're going to want to do is I'm going to come here and I'm going to type this into my UI. You're going to do port 9000 or port 9001. Yeah, so you want to do port 9001. And then what you're going to do is you're going to type in admin, and then you're going to also type in admin. And that's basically the username and password for the administrative account. That is the default. And it's when you log in the first time, what it's going to do is going to have you change that password. So I'm going to change this password to something that I'm going to remember. And I'm going to basically update it so you can see that it has also been updated. So now what we're going to do is, in this particular case, it says, how do we want to create our project? So the project that we're going to be scanning, or the code base that we're going to be scanning, is actually a vulnerable web application that I pulled from GitHub, and I'll explain a little bit more into detail what that is. But we're basically going to set this up here, and when it's going to navigate us to the create a project dashboard or screen. We're going to come here and I'm going to type in test vulnerable app, and the main branch is just going to be main. So we're going to set that up, but this is important, the project key, which is basically going to be a unique identifier for the project in SonarQube. So I'm going to set this up, and you can see that it gives you multiple options on how we want to basically analyze our repository. In this particular case, we're going to do everything locally because we're running it from Docker, or we're going to be running the Sonar Scanner from Docker. So with that being stated, what we do is we're going to click on it, and then we're basically going to generate a token that's going to last us for 30 days. And what I'm going to do and what you're going to do is copy this token, and let's just kind of paste this somewhere where we're going to remember it. I'm going to paste it in a README file for now. And then I'm going to kind of navigate right on back to this. I'm going to click continue. And then for the analysis on our project, I'm just going to pick other. And of course, you're going to want to pick the OS that you're running. For me, I'm using a Mac. And then from there, it's going to give you the SonarQube, or I'm sorry, the Sonar Scanner command that you're going to want to run. In this particular case, I already have it in the file, so you don't necessarily have to worry about that. So what we're going to do is we're going to navigate back to where we were, and I'm going to basically come to this file that I have, or this folder that I have with the vulnerable web application, which is basically checked out already. So the link to this web application will be in a description. Just make sure you go to the Git repository and just clone it, or fork it over into your own GitHub repository or project. So I have this code base here, and it's basically a Python application with a couple of other things. And I want to scan it, and I want to see what type of results it's going to bring up to me, right? So what I'm going to do is I'm going to copy this command, and I am going to basically execute this command in this shell. But the key thing I want you guys to understand is that for this particular command, there's a lot of things that it's doing. And I have the instructions written to describe each part of this particular command that we're actually going to be executing. So with Docker run, when you execute that command, it's basically used to run a container. The RM flag ensures that the container is removed after it stops running, so it kind of cleans up after itself. The tac network equals host is really the flag that specifies that the container should share the networking namespace with the Docker host, which basically allows it to interact with the containers that are running within the Docker's virtual networking environment. The thing that we're passing in here is basically the environment variable. So we're saying, oh, this is a host that we want to connect to. It basically defines the URL of the SonarQube server or scanner for it to connect to, and so on and so forth. This tag v is basically where we're mounting the volume for the host machine to the container. So in this particular case, I'm basically giving you my absolute path, and you're actually going to want to do this as well to the folder where the project is that you actually want to scan. So in this particular case, if I do pwd, you'll see that this is the absolute path to this folder that I want to scan with all the contents in it. So I'll be sure to add that into my command. The Sonar source Sonar Scanner CLI basically specifies the Docker image that we want to use. So we're going to be using the Sonar Scanner. And then these flags are basically going to be passed in to the Sonar Scanner for it to be able to map all this scanning results to the project itself. So now that I've kind of covered that for you guys, I'm just going to basically copy this command that I've written. And of course, this will be cleaned up for y'all. And I'm going to run this command against this product. Bam. So you can see that it's basically going to download the Sonar Scanner. And it's going to take a little bit of time. And while it's downloading the Sonar Scanner, it's basically going to execute the scan and publish the results to the project that is associated with, called Test Vulnerable Web App. So this project key is basically where the results are going to be populated in the SonarQube web application. And with that, I'm going to say this is going to take a little bit of time, maybe 9 to 10 minutes, at least the last time I've ran it. So at this point in time, while this is running, I will recommend you go get a cup of coffee or get you a beverage and just come right back. All right. So real quick, if you ended up running into an error when you executed it, just know that this part was wrong. So I put web app here instead of app. So just make sure that your project key is correct. Test vulnerable app instead of test vulnerable web app. And also make sure that you put your sonar.login token here. Don't use mine, which it won't be there when I commit these changes anyway. So now that we've done this and you can see that the execution was successful, what we're going to do now is log into the SonarQube console and review the changes so we can see what all it caught, right? And you can see that the overall quality gate status passed. One thing I want you to know is that the quality gate is basically a set of measured based Boolean conditions that really lets you know whether or not your product or your code is production ready. This can be customized and you can set your own like set of measures based on a particular project. We haven't set that here and I don't think we really need to, but you could just know that this is actually a really nice feature to have because you can eventually add this into your pipeline to block changes that fail the quality gate. But you can see that based on the things that have been scanned, there are 4 different categories. Well, not 4, but multiple different categories. But the one thing that I really wanted to identify with you guys is the vulnerability section. So there's bugs, security hotspots, and then the maintainability. But the security section is where we're going to really focus on. And you can see that in the app.py file, it was able to find several different security vulnerabilities. So if we just click on one of these, you can see that it says that the main topic or title of this is enable SSL certification validation on this SSL TLS connection. So you can see that here we're basically not validating it at all because the verification is set to false when it should be set to true. And you can see that if we tag it, there's so many different tags for it, like CWEs, there's OWASP, privacy, SSL, so many different other tags for it that can map back to what has already been created, logged by, OWASP and the CVE repositories and so on and so forth. And if you see, it basically tells you where the issue is, and it also tells you why it is an issue. So if we wanted to take another look at, let's say like code smells or anything like that, we can basically come here and look at the code smell, which is essentially telling that, hey, define a constant instead of duplicating this literal index.html 3 times. So SonarQube is really good at eliminating duplication and making sure that, your code is as clean as possible. So if you're that one type of person that likes to practice clean code and making sure that, you're not duplicating the lines of code and making sure that your code is as clean as possible, SonarQube is really good at making recommendations on what should be parameterized versus what should be in the config file and so on and so forth. And you can see there's plenty of places where it's basically telling you like, hey, these are code smells and these are things that you really, really need to take care of. And you can see that in the Sonar source, when it comes to security vulnerabilities in the security category, you can see that there are various different types of sources. So you can have security vulnerabilities that fall underneath OWASP top 10, OWASP top 10 from 2017. You got SANS top 25, the CWE. There's so many different things that it can pick up. And that's one of the things I really wanted to show you guys. Now, when it comes to security hotspots, there's also various different types of things that they also want you to implement as well, or you could implement. And this is basically like, for example, risk, what they view as a risk. And you can see here is basically saying that password detected here, review this potentially hard-coded credential. So you can see that this credential is hard-coded and it's basically telling you that you should really review this risk and see if you really need to eliminate it. And you can see that in the past, this type of authentication problem or security risk has been identified. So it maps it back to CVE and to OWASP, which is absolutely critical for you guys in regards to scanning your project with SonarQube. There's a massive benefit towards this. And that's why I definitely think that SonarQube is one of the best SAST scanning tools out there. And that concludes this video, y'all. Thank you so much for watching. I hope you guys were able to take away things about SonarQube and the Sonar Scanner and really scanning your applications to find vulnerabilities and leverage SonarQube as a SAST scanning tool. Please make sure you like, subscribe, and drop a comment down below letting me know what you think about this video and letting me know what you think about the channel overall. Thank you again so much for your support, and I can't wait to see you all in the next video. Later.